Of every world beyond Earth, this is the one we've dreamed about the most. We've written it into 1,000 stories. We've sent it more robots than anywhere else. We talk seriously about moving there someday. Mars is the friendly one, the hopeful one, the planet we call our future backup. So here's the uncomfortable truth. Step onto the surface of Mars without a suit, and that friendly red world will kill you in about 2 minutes. The water in your body will start to boil. Your lungs will find nothing to breathe, and you'll black out before you even understand what's gone wrong. If Venus tries to kill you with too much heat, too much pressure, Mars does the opposite. Mars kills you with too little air, too little pressure, too little warmth. So let's step out onto the red planet and find out exactly what too little does to a human body. Mars looks approachable. It's a rusty desert of red rock and dust, with dune fields, dry riverbeds, canyons, and the tallest volcano in the solar system. From orbit, it looks like a place you could hike, a cold Arizona, a rough Sahara. And in a way, that's fair, because Mars really is the most survivable planet we know of, other than our own. But most survivable is doing a lot of heavy lifting in that sentence. It doesn't mean survivable. It means it takes minutes to kill you instead of seconds. On Mars, everything that would keep you alive is present, just in doses far too small to matter. There's an atmosphere. It's just almost not there. There's warmth in the sunlight. It's just bled away almost instantly. There's water. It's just frozen solid or locked underground. Mars is a world built from the ingredients of home, mixed at concentrations that quietly, patiently kill. Let's say you step out. The first thing that greets you is the sky, and it's the wrong color, not blue. A dull, dusty butterscotch, sometimes pinkish, tinted by fine red dust hanging in the thin air. And at sunset, strangely, Mars flips Earth's palette. The sky near the setting sun glows cool and blue. The ground is rusty red in every direction, iron in the soil, literally rusted. The sun looks noticeably smaller and weaker because you're half again as far from it as Earth is. The light is dimmer, colder, flatter, and it's quiet in a way nowhere on Earth ever is. The air is so thin that sound barely carries. A shout a few meters away would come out faint and wrong. Two things about Mars will feel oddly familiar, though. A day here is 24 hours and 37 minutes, almost exactly our own. And gravity is about 1/3 of Earth's, so you'd feel light, bouncy, able to leap nearly 3 times higher than you can at home. For a moment, it might even feel pleasant. That moment is a lie, because Mars has already started taking you apart. Take a breath on Mars, and there is almost nothing to breathe. The Martian atmosphere is about 1% as thick as Earth's, 1%. And what little there is happens to be roughly 95% carbon dioxide, with only the faintest trace of oxygen, nowhere near enough to keep you conscious, let alone alive. On Earth, even on the peak of Everest, you're breathing 1/3 of the air you'd get at sea level, and people can barely function up there. Mars offers you a tiny fraction of that. It's not thin air. It's essentially no air. Your lungs would heave and pull and find nothing useful coming in. By itself, that lack of oxygen would knock you unconscious in well under a minute. But on Mars, the missing air brings a second, stranger problem, one that has nothing to do with breathing at all. This is the part that sounds like science fiction, and it's completely real. High above the Earth, there's an invisible line scientists call the Armstrong limit. It's the altitude where the air pressure drops so low that water boils at the temperature of your own body. Not because it's hot, because there's so little pressure that liquid water simply can't hold itself together anymore. It tears itself apart into vapor. The entire surface of Mars sits far, far below that line. So, the moment you're exposed, the water in your body starts to boil. Not from heat, but from the near total absence of pressure. The saliva on your tongue would bubble and fizz. The moisture on your eyes would begin to boil away. The water lining your lungs would turn to vapor. Gas would come out of your blood and swell up under your skin. Now, Hollywood loves to show people exploding in a vacuum. That part is a myth. Your skin is tough and elastic enough to hold you together. You would not burst. But you would swell, you'd bloat, and inside, things would be going very wrong very fast. Combined with having no oxygen, you'd lose all useful consciousness in about 15 seconds. Not minutes, seconds. So already, in the time it's taken to explain this, Mars has suffocated you and started boiling you from the inside. And we still haven't talked about the cold. Mars is brutally, bitterly cold. The average surface temperature is around -60 degrees Celsius. That's about -80 Fahrenheit, colder than the coldest place on Earth. Near the poles in winter, it plunges to -125 Celsius, cold enough to freeze carbon dioxide out of the air into dry ice frost on the ground. You'd expect that to flash freeze you solid. But here's the counterintuitive twist, and it's a great one. It wouldn't. Not quickly anyway. Remember how thin the air is? That same thinness that's suffocating you also means there's almost nothing there to pull the heat out of your body. On Earth, cold air and wind strip your warmth away fast. On Mars, the air is so sparse it can barely carry your heat off at all. So paradoxically, on one of the coldest surfaces in the solar system, freezing to death is the slow threat. The suffocation and the boiling get you long, long before the cold ever finishes the job. On Mars, the cold isn't the assassin. It's the undertaker. It only matters after everything else has already won. Now let's clear up the most famous Mars myth of all, the killer dust storm. You've seen it in the movies, howling Martian winds tearing across the plains, strong enough to knock over rockets and hurl astronauts through the air. It makes for great drama. It's also almost entirely wrong. Mars does have dust storms, enormous ones, sometimes swallowing the entire planet for weeks. But because the air is so thin, even a powerful 100-mile-per-hour Martian wind would feel like the faintest breeze against your hand. There's simply not enough air there to push with any real force. A Mars storm could never topple a rocket or bowl over a person. That part of the story is fiction. The real danger of Mars dust is quieter and nastier. It's incredibly fine, like powdered talc, and it clings to everything: solar panels, seals, joints, visors. And the soil is laced with toxic chemicals called perchlorates, which are poisonous to humans. So the dust won't blow you away. It'll choke your machines, coat your equipment, and slowly poison anyone who breathes it in. Not a dramatic death, a creeping, grinding one. There's one more killer on Mars, and this one you'd never see, feel, or hear. Earth protects us with a powerful global magnetic field and a thick atmosphere that together shield us from most of the radiation pouring in from space. Mars lost its magnetic field billions of years ago, and its atmosphere is a whisper of ours. So the surface is constantly bathed in cosmic rays and solar radiation at doses that would be dangerous over time. This isn't a 2-minute killer like the boiling or the suffocation. It's the long game, the threat to anyone who might actually try to live there. Raised cancer risk, damage to the body over months and years. It's one of the biggest problems standing between us and a real Mars colony. Not how to survive the first 2 minutes, but how to survive the first 2 years. Let's settle it the way we always do. On the surface of Mars, unprotected, what ends you first? It's a dead heat between suffocation and the near vacuum. With no oxygen to breathe and your body fluids boiling from the lack of pressure, you'd lose consciousness in roughly 15 seconds and be gone within about 2 minutes. The cold, the toxic dust, the radiation, all real, all deadly, but all far too slow to matter. On Mars, you die from what isn't there before you ever suffer from what is. So Mars sounds like a death sentence, just a slower one than Venus, and unprotected it is. But here's why we keep dreaming about this particular hostile world, and it's the exact opposite of Venus's answer. On Venus, the only survivable spot was floating 50 kilometers up in the clouds because the ground itself was pure hell. On Mars, the ground is where the hope is, because Mars is the one deadly world a human could realistically walk on, not in a crush-proof deep-sea suit, not in a floating cloud city, but in an ordinary pressurized spacesuit. Think about what Mars actually offers. A day almost exactly as long as ours, gravity you could stand and work in, enough sunlight to run solar panels, frozen water at its poles and buried in its soil, water you could drink and split into oxygen to breathe and fuel to burn. Every ingredient for a foothold is already there, too little to keep you alive as you are, but maybe just enough to build a life on top of. That's the strange magic of Mars. It's a world that would kill you in 2 minutes flat, and still be the best shot humanity has at ever calling somewhere else home. So, could you survive on Mars? Step out unprotected, and no, 2 minutes, and the red planet takes you apart with everything it doesn't have. But bring your own air, your own pressure, your own warmth, and Mars just might let you stay. It's the deadliest place we may one day live, a planet that could kill you before you finish reading a page, and still become the second home of the human race. If you made it this far, you've got the patience it'll take to build a world from scratch. So subscribe and stick around, because next time we're going somewhere new to ask the same simple, terrifying question. Could you survive there?